Greetings from Dystopia, episode 50. On my way back over, gonna walk some of the I&M today. Probably not gonna shoot a lot of video today. Most of today is gonna be on the bench. We'll build the Raspberry Pi 4 into the Neo case and get that set up, and then probably put in part 2 of the camera setup. I found 2 fairly decent programs. One of them assumes some photographer knowledge, but they're both pretty straightforward, so we'll get that going here in a little bit. Alright guys, see you in a bit. Hey folks, we're on the bench. As a quick follow-up to the Raspberry Pi camera setup, what we have here, one of the guys messaged me directly and had asked about his son. Let me switch over to the computer here. His son is already taking Python in school, but he's having problems accessing the camera in Python. And it's actually fairly straightforward. I'm not sure exactly why he's having that problem, but the basic things he needs to set up are the variables. That's probably, and I can't get the full variable to come up, can I? No. It's one of the things I hate about Thony, or Thony. I've heard it pronounced Thony, Thony, and Tony. Typically I do my Python stuff from the command line in Pico. Those of you who have been around Linux and Unix for a while probably know Pico. But yeah, the question is he can't get the camera to work. Basically, he needs to set the variables, and he's probably, what's getting him is the variables themselves, because you need to reestablish it from PyCamera to PyCamera with capital P, capital C. And then obviously he needs to get the time variable for the sleep function to work. So all I've done here is just written a quick one. Set the variables. We're defining the camera. We're defining the camera there. Okay. We're going to start our preview with that command. The preview starts is put to sleep for a count of 5. And then we end the preview. It's just that simple. You'll have to be more detail of what problem your son's having, because this is really straightforward. And my guess is it's that variable that's kicking him right there, is that he has not defined it, because that is the change, is the case sensitivity in the name. And make sure the camera object is set. Other than that, I mean, there's nothing really too difficult. I'm going to turn the webcam now and point it at the screen, because it does not capture the video from the overlay of the photo. But hang on just a minute, let me switch this camera. Okay, so now that I've got the camera repositioned here, I mean, yeah, it's really straightforward. I'm not quite sure what's going on, but just to show you, because you didn't mention that he's using Tony, that's why I opened this one up. But so I just have him test it this way with the code. I will put the code in the comment or in the description for tonight's episode. It's really straightforward, but the only catches are if it's upside down. I gave him the actual camera rotation command. So it can be 90, 180, or 270 to flip the camera view around. Again, we're starting the camera preview. We're going to sleep for 5 and we're going to stop. But here I'll just run it. And just, oops, I should have realized that quicker here. I'll hold the Raspberry Pi 4 box over the camera. We'll run the app. So that's it, and it works. Yeah, unless he can be a little more detailed with what's going wrong. But that's my suspicion, is when he actually set the variable, he didn't capitalize it. So PyCamera lowercase. From that device, we're going to import that name as Pi camera, capital P, capital C. So let me know. Okay, and the next question that came up, as I get my soda opened up here. Sometimes it's hard to beat a Diet Coke. Okay, so we've shown, at least in Python, how to activate the camera. Next question came from my daughter, and that was a discussion that she and I had following up with, we built the, let me switch cameras here. We built the Raspberry Pi for the van with the touchscreen. And in that video, I had mentioned doing time-lapse photography with it, and she had asked, how do you do the time-lapse? There's a gazillion different ways to do it. Just like everything, there's always more than one way to skin a cat. I just figured basically I'll show you the Python way. This is a piece of code I borrowed from somewhere else. It's a wonderful thing with Raspberry Pi. For a lot of coding nowadays, you just find the code that works and you modify it from there, or write it from scratch, either or. So basically this is a one-day bit of Python. So again, we're importing, in other words, time. We need to know what the time is, what our camera is. Well, it's the default Pi camera. We're going to do a video for 1 day, 60 frames per hour. Frames equals frames per hour times 24 times video day. Very simple, little bit of math. I mean, this is no difficult coding here. And we're going to save it to the desktop. We're going to capture the images. Check the time before capturing. Write the time as part of the file name. The clock just sits and waits. Does its little bit of math to know how long it has to wait. Then it goes back up, starts the loop over again. This is really straightforward. Actually, we can do this as a channel project, if you will. I will set this Pi up tonight or tomorrow. I will set it up and let it record for a full 24 hours looking out the window, and we can just see what we get. The first thing we need to do, though, is sudo install FFmpeg. Sudo apt install FFmpeg. And that's to ensure that we have set to manually installed. Why? Okay. Now I got to figure this one out. Well, I started doing this without recording it, and I should probably record it. First one I found was that a library could be corrupted, so they said to do an auto remove or an apt remove. So we're going to uninstall FFmpeg, wait for it to finish, and then we're going to try and reinstall. Actually, I should probably do a purge after this, but let's try it. Let's try it without purging. There we go. Okay, so it was right. Something was corrupted in the install. What happened is probably a library got replaced and it panicked because the library might be newer. Just to make sure now, since we did that, let's go back up and run just a quick one. You can't see it, but I just took a shot with the camera to make sure it is still working. So yeah, our camera's still good. Yeah, I wonder if that was my problem with VLC the other day. Okay, the reason why you have to install FFmpeg is when we run this script. Let's go back to our script here. When we run this, it is going to create a ton of files on our desktop. There'll be individual pictures. And what we need to do to turn those back from pictures to a video is use FFmpeg, right? It's going to start with the image name, our location, the frame, day number, right? And we're converting it to a H.264 codec, high color codec, or high color profile, slow, and we're going to output it as an MP4. So that's it. And it's straightforward, but you're going to have to learn. This is what I was talking about with the command line. This is why I'm looking for an easier app for you guys to use just as a program from the desktop. But so that's it. So I will set this up, like I said, tonight or tomorrow morning. I'm going to, let me switch over here to the desktop. So I will, our next video is hooking up the the Neo case with the Raspberry Pi 4 camera. With the Raspberry Pi 4, what I will do is, after that build, I will install this camera onto the Raspberry Pi 4, because if you guys remember, we have this little pod right up front here that's actually made to hold the camera. So we will use this as our basis for the camera. I'll set the camera out the window, and we'll do a 24-hour time lapse and just see what happens out the window. Probably see nothing but grass growing and kids, but you never know. I used to do time lapses out of my window at my last place, and the amount of traffic that goes through and the grass cutting, and it always made it pretty interesting. But right. Okay, so as I sat down to start doing this, my everything kind of fell apart with the plan of putting this together today, but we will go ahead and soldier on with what we have. I realize that I do not have my micro HDMI to HDMI adapters. I can't find my thermal paste, which means I have to trust their silicone pads, which, for the record, are fine. I just prefer thermal paste. I'm kind of old school. I prefer to use the old-fashioned paste. But again, we're using the Argon Neo case and a Raspberry Pi 4. We're going to go ahead and mount it today. I ordered the correct HDMI adapters because it doesn't look like I'm going to be able to get into my storage unit anytime soon. So we're going to install our two pads here and here. If you're not familiar with these, they're just thermal transfer pads. It is silicone. Once they heat up, they will transfer the heat over. I cannot remember if there's a sticker on this back side. That's why I prefer, it looks like there is. There it is, yep. Sorry, I'm doing that off camera. There's a sticky on each side of this thermal tape. This is a silicone paste. It will turn to liquid when it heats up, but I prefer to use the paste. Just that old school. I've learned to trust only the paste. So we have placed one on the processor, one on the graphics. We're going to invert this down into the Neo case. Make sure we're seated properly. And then their bottom, again, you just have to check the orientation of the bottom. The biggest giveaway on this one to check the orientation is look for the micro SD port. Make sure that it's lined up. And before I go any further, let me check the focus on that camera. Yeah, that's good enough for the purpose of the video anyways. Okay, and then you're going to turn the case. This is really straightforward. It doesn't get much more difficult than this. And again, just like doing, you know, your lug nuts or whatever, do them in an opposite pattern or in an every other pattern so that you get a nice secure mount. Do I need to make another video on how to make the make the micro SD? I don't remember which episode that was in, but there's one up there already on how to make the micro SD card. If you need help again, let me know. I can do another screen capture. I'm just putting the little anti-slip feet. Yeah, and somebody asked me about this pad, and I forgot about that. I think it's made by Fiskars. The scissor and knife guys, but I got it at Walmart. This is the 24 by 24. No, I'm sorry, 24 by 18 pad. And I also have a small pad. So now we're all mounted up. All our ports are exposed. That's the other thing I love about this Argon. They really think through their cases. I mean, they're so well thought out. Remember, our heat tape is right here, underneath here, to transfer heat to this outer metal case, and it turns the case into the heat sink. But the ports are laid in such a way that I can still get my finger in there to, you know, release for the ribbon cable. All the GPIOs are exposed perfectly. He did such a good job with it. Oh my lord, I have 2 extra screws. But yeah, dude, I love the Neo case. It's just simple, straightforward. There were some questions on the equipment, the camera I'm using. I started working on a video, but I have not completed putting it together. But in fairness, we can talk about the camera, just to give you guys a little bit of extra video. Because by the time I edit this down, it'll be a short one. And I know most of you guys are going, God, keep it short. The question was, what camera have I started using? And I know I talked about this before, but I didn't actually show you the camera. This is the DJI Osmo Pocket. If you're familiar with DJI from drones, from gimbal platforms, they make professional gimbal platforms. So this is a fully stabilized gimbal camera. And there is no SD in it right now, but just to show you, I have a little bit of control. I think I'm going to exceed the limit of, yeah. Oh, I went down. I need to go the other way. Turn this up to you guys so you can see the actual eye moving. You can see the stabilization as I rotate the camera. It's doing its best to stay stable. So yeah, that's what I've shot the videos off of this last week. We're all done on this. Full 4K. I played around between 4K and 1080. There's a little cover that goes here, but I'm showing you how it comes originally from in the box. You get a pretty nice little case that comes with it to actually protect the camera. And that's fine if you're not shooting on a handheld rig, which I do. So initially I had bought this gimbal cover, this gimbal protector, which I didn't care for because it left the screen exposed. Yeah, it protects the gimbal, but the back of the gimbal is still exposed. So I wasn't too keen with that one. So I bought this one, and it was actually $1 more, which was stupid, but I didn't see it initially. It was only watching somebody else's video that I realized, hey, they have a gimbal that gives it a cover that protects the gimbal 360 degrees, and it also protects the screen. So that was an $8.99 piece of insurance. It's one of those deals I wish I would have seen that first. I did post the video the other day talking about the oh, there it is. It's down in here. So I'm waiting on some more parts to come in for the small rig. So now it's inserted in the small rig case, and we're just going to screw it down. So it's a very snug fit in there. This will be the piece that actually attaches to my tripod, to my, I don't know, I guess you could say selfie stick / tripod. Let me grab the microphone. Oh, actually, it's right here. This is how I had it rigged on the way over for the opener of today's video, just so you can see it. And the reason why I'm sticking with this base right here for now is it protects this cable, this connector, from getting hit. But yeah, this is the way I shot the opening video this morning, just facing right at me. But yeah, I ordered a couple more components from Small Rig. They're little friction mounts that are 2 inches long, so one will come off of the side here and go up to support the camera mount, the phone mount, which is actually, give you guys a little bit of height here. And get it off this tripod if I can. Right, now that it's off the tripod. So what I'm going to do is, that was dumb, almost dropped it on the other camera back there. So what we will do is come off of this, off of this mounting point right here is going to come that little friction arm, and it will hold the camera mount out to the side here, because there's a key component as an interconnect that slides in there, and then the phone, oops, that's right, I can't put it on with that cover on. So this slides in place like that onto the lightning connector. And then this back slides over like that. So what I have to do now with that friction arm, wow, that thing's got a lot of fingerprints on it. Yeah, maybe that'll make the fingerprints go away. But yeah, I'm going to come over with the friction arm, come down at a slight angle, and go up and catch the 1/4-20 here, so that that is supported as a full unit. And then I have to figure out the mic position from there, which will probably be another friction arm. I did order 2 of them that will connect into the bottom over here and bring that cold shoe. You know, if you think about how your flash mounts, this is a cold shoe. It doesn't have an electrical connection, and it will hold it down below the camera so that it never gets in the view of the gimbal. And that's it. But yeah, if you're looking for a 4K capable camera, but you're worried about size, I'll tell you, you cannot go wrong with this DJI. I've been absolutely amazed at the output from it. You've seen the videos that I've shot out in the field, so to speak, the last week have all been shot on this gimbal camera. So Fred, if you're paying attention, Fred is my oldest brother. So I will move the gimbal up and down with the thumb control. When it is actually connected to the camera or to the phone, I'm using the phone as the screen. I get a larger gimbal button, so we'll shoot down onto our, and it's a little close for it. There it goes. So here now we're going to tilt over. We're looking at that Raspberry Pi and the camera, which you can now see in that reflected view. But yeah, it's a great rig. I'm totally in love with this thing. There's some little points, little bothersome little things about it, but that's kind of why I'm building this cage, to get around it. I can tell you, for me, the one big problem with it, it's too small. They should have made it about an inch longer. And I say that for multiple reasons. Number one, I have big bare paws. So this, there's not much to hold on to here. So giving it the extra 3/4 to half an inch to hold on to would be nice. They could also increase the battery with it. Another problem I have with the onboard mic, you can see that hole. There's 2 onboard mics. There's one there. There's one down here in the bottom. Noise cancellation is okay, but you can't put any type of a windscreen on it. There is a foam sock that fits around it that somebody has made that, lowers the wind noise. They cut a hole in it to get to here, but it's not a good solution. The other thing is it's not a stereo record. In this small device, there's no reason why they can't put a microphone on each corner. So you have 4 mics surrounding the case. So you could, as the gimbal rotates, the logic can say, okay, I'm looking this way. So you can see I'm looking to the right now. So I should be using, a mic here and a mic back here to give me stereo audio this way. Oh, okay, now I'm facing up. Now I should use these 2 mics to give me stereo audio this way. Same thing as you go around. So just by adding 4 corner mics, they can create an array that Logic can take audio from to continue stereo sound. Giving the half inch, again, increases to a larger battery, gives them room to fit in that mic array. You could move the buttons up or down depending on how much bigger you made the case, and allow for a collar, a foam collar, to be inserted around to protect the noise from wind noise. I mean, if you notice, my daily mic is the Rode Video Micro. It has a dead cat on it for that reason, to stop wind noise from audio. So there you go. That's my little hints. All right, guys, be good, be well, and we'll see you tomorrow. All right, guys, have a good one.